So in this video, we're going to talk about what is a CNC program. Um, we're going to be dealing with a G-code system, which is the most common way to program a CNC. And the industry standard is the FANUC control, a Japanese control FANUC. So there are quite a few different controls that can be on a CNC. We've got Siemens, we've got Heidenhain. They're both German controls. We've got Mazatrol, which is on a Mazak machine, which is another Japanese control. And then we've got Haas, the American machine tool builder, who have Haas have got their own control, but it's very similar to the FANUC control. And if you put a FANUC program into a Haas machine, it would work. So this G-code system, it does conform to an ISO standard, although there are loads of variations on this. But generally, this G-code system is common to most controls, but you will see loads of different types. But what we're going to deal with is the FANUC because that is the most common control. And when we're talking about the control on the machine, what we actually mean is the computer. So each machine has got a computer that controls the machine, and that system that a bit like any software, and that system is what we're talking about when we say it's a FANUC control or a Siemens control or whatever. So the machine tool, the actual bit that does the machining, the physical machine, it can have a different control. So you could have two machines from the same company, but they might choose to put a different control on it, a bit like putting a different engine in a car or something like that. But these controls, try not to get confused with them because we're going to deal with a very generic one, which is the FANUC one, which covers most machines. So the G-code system, the G-code system's used in routers, woodwork routers, and it's used in all these metalwork, metal cutting type machines. So this is my CNC program that you can see here on the screen, and it does look rather complicated if you're not used to seeing these things, but you'll notice this has got gaps in it and it's well spaced out, and that is to give it clarity. And this program begins with a unique 4-digit program number. It begins with the letter O. If you look at that red O, that is a letter O, not to be confused with the number 0. So on your keypad, just like on your computer, you've got the number 0, but you've also got the letter O. So it begins with the letter O, and then it's got this 4-digit number. It ranges from 1 to 9,999. This is typical of most controls. Some go higher, some you can even use a name for your program, but we're talking about this type of program where we use a number. So it's a 4-digit number, and then after that I've got a description. So on any program, when we use curved brackets, we can write comments in there. And if you then jump right to the end of this program, you'll see that M30, which means it's the end of the program. So it starts with a number, ends with this M30, and this M30 tells it that this program is finished and it will stop and jump back to the beginning. So that's our program. And in our control, we can have loads and loads of these. So we've got our memory, and in our memory we've got loads of these programs stored, and it depends on the size of that memory as to how many we can have in, but we can have up to 9,999. But obviously if it was one great big program, then it would fill the memory up. So we've got loads of these programs, and when we hit the cycle start button on this program, it effectively makes a part. So that's what this program does. And if we look through the part, you'll see the first thing that it does is picks up a tool. That's this TO1M6. That's a tool change. So that means get me a tool. M6 means change the tool. And what tool do you want? Well, I want tool 1. Then I'm going to move to a position. So the G0, that's a rapid move. I'm not going to tell you every single G code because it would just really complicate this, what I'm trying to show you, because this is an overview of a CNC program. So this G0 means rapid, and the XY is the position. So this is rapid in this tool. I've got a description of this tool, says it's a 25mm spot drill, and I'm rapid in it to a position. And then what I'm doing is I'm starting my spindle. M3 means start the spindle. So I'm giving it a speed 3000 RPM and starting the spindle up. And this G43 that you see there tells it to bring the tool down, and it allows for the length of the tool. So that H1 corresponds to tool 1, and it then looks in to the memory, the offset memory, at the length of that tool, and it will now allow for the length of that tool when it brings it down. And then the M8 there, that M8 is turning on the coolant. So this is turned on the liquid that cools the tool. So the tool's down there, and it's all ready to do something. And this G81 is called a drilling cycle. So it tells it to drill a hole. You'll see a Z -6, that's the depth that it's going to drill to. It's also got a feed rate, F200, it's going to feed at 200 millimeters a minute. And then it's got another position, so that means it will drill another hole. And this G80 says stop drilling holes now. And then it turns off the coolant, this M9, turns off the spindle, M5, although that's not always necessary, but I'll put that in there so you can see it. And this line here, G28, G91ZO, tells it to take the tool back up in the air. So it takes the tool back up, ready to do a tool change for the next tool. And then we get to repeat the whole process again. So now it's picked out tool 2. So this is a 14 millimeter drill, and the M6 again tells it to do a tool change. So that's told it to pick up another tool. And then this next line, you'll see I've got a position, I've got a G0 rapid, 2A position, but this time I've done loads of stuff on the same line, which is okay. I've started the spindle at 3000 RPM on this same line. So it'll move to position and start the spindle all on that one line. Then it brings the tool down again, and turns on the coolant. And now it's got a different drilling cycle, different depth, same feed rate, move to a position, and then this G28 takes it up in the air again. And my last tool, this tool 3, is a tap. So this is telling it again to move to a position, start up the spindle, and this G84 tells it to do tapping, to tap a hole, so produce a screw thread. And then I come to the end of my program. I've finished all this now. It's just 3 simple tools. It could be anything. And then it goes up in the air, Z0, and then takes the Y back. So it moves the part towards the front of the table so that I can just take it off and change parts. And the M30 says stop and rewind. So it jumps back to the beginning, but it doesn't carry on. It waits for me to press the cycle start again. So when I've loaded another part, I can run it again. So that's a CNC program. That's a really quick, you're not expected to understand all this. We will be doing a lot more further on, but this is to give you a brief overview. So don't get too bogged down in the minutiae. The idea of this video is effectively to say, well, what is a CNC program? And that CNC program is a set of commands for this machine. It tells the machine what it's got to do. And every time we hit this button, this is called program number 1. And whenever we call out program number 1, it will do this same set of commands. So this can repeat over and over again. And then if we put this part away and we don't make them for 5 years, we can come back, pick this program out and run it all again. The only thing that we have to do each time is set the tools up. The program won't change. So we have to set up all the tools ready to use, and we have to set up what we call a datum. In other words, we have to tell it where the part is on the table, which again we'll be talking about a bit further on in the course. So that is effectively what is a CNC program.